Hello students, welcome to the series of lectures on digital speech processing. So in this video, we'll be able to learn the topic of basic pattern recognition approach in automatic speech recognition. Okay, so this is the second part of the unit number 3. In the first part of the unit number 3, we have already completed the enhancement techniques, okay, for the speech signal. Okay, now let's get started with this. Alright, so on completion of this lecture, you will be able to understand the basic pattern recognition approaches. Now, one second, let me enlarge this so that you can easily. Alright. Automatic speech recognition. It is a process by which an acoustic speech signal is converted into a set of words. Okay. So that is the main goal of ASR. So when you give the acoustic waveform, that the speech signal as an input it is taking. Okay, you are going to be developing or designing a machine that is ASR, automatic speech recognition. So for which you are applying input to the acoustic waveform or the speech signal, and we are expecting at the output of ASR should be the written format, that is the text of format that we are expecting. Okay, that is the main important goal of ASR. So the basic pattern recognition approach to the speech recognition, which involves the following steps. The first one is the data acquisition, and second one pre-processing, and feature extraction, and some other properties. Okay, so let us start our discussion with the first step, that is data acquisition. We collect the audio signals which contain speech patterns of our interest. Okay, so any kind of an audio signal that you can wish to process, that you are going to be taken into consideration. Next, pre-processing. So we are going to be applying the DSP techniques to the audio signals to remove the noise if at all any, and filter out irrelevant information, and we need to enhance the speech signal. That's the second important step we are doing here. And third one, feature extraction. So transform the pre-processed audio signals into a set of features that represents the speech patterns of our interest. And this could involve techniques such as MEL frequency substral coefficients, that we are calling in short MFCC. This is most widely used technique for extracting the features. Anyway, in the second unit we have already completed a topic called linear predictive coding. The linear predictive analysis for the speech. Okay, LPC is also one way how we are going to be extracting the features from the speech signal. Okay, but most widely used technique is that MFCC. That also we are going to be learning in this video. Okay, so that we are going to be having for the extraction of the feature that can be positive. Next, so the fourth important step is that we are going to be building a statistical model of the relationship between the extracted features and the corresponding phonemes of the words of the language being recognized. This is also very important technique. So in the acoustic model, we are going to be using the hidden Markov model process. That is the best suitable method for modeling the acoustic waveforms. Okay, so what we are doing here is that we are going to be building a statistical model of the relationship between the extracted features and the corresponding phonemes of the words. Okay, so the last one is the language modeling. So we need to build a statistical model of the likelihood of the word sequences in the language being recognized. So these two are very important for us. Okay, so to build the statistical model, first we are going to be looking for the acoustic and then language model. In the acoustic model, we are taking the help of the method called HMM, hidden Markov model process. Okay, that also we can see in this unit. And the next one is the language model. Okay, so language model, that means what we are doing actually here is that briefly I will explain what exactly the language model is. So we are going to be looking for the output of ASR is the written words, right? The text message we are going to be looking at the output of ASR. Okay, so now in the language model what it does, it is going to be has to be predict what is the next word that can be spoken by the speaker. Okay, so what we are doing here is that we are going to be applying the probability of the words, and we are expecting what is the next word that can be spoken by the speaker, and that can be understandable in a meaning way. Okay, so that also we are going to be looking here. Next, decoding process. So use the acoustic and the language models to decode the speech signals and determine the most likely sequence of the words that corresponds to the speech input. Okay, that is also very important thing that we can do. So this can be happens after designing the acoustic model and then the language model. Okay, now evaluation. So we need to measure the performance of the speech recognition system using appropriate metrics such as word error rate or the sentence error rate. So this is an evaluation process. Okay, so these many steps which have been involved, okay, in the pattern recognition approach to the speech recognition. Now, so what is the traditional pattern recognition model for the speech? Okay, so we can see from the block diagram the speech that you have recorded that can be given as the input to the feature extraction, and we have the test of templates we are going to be already trained. Okay, now we are going to be comparing the pattern matching. We are going to be comparing that with the feature extraction after getting that with the reference template. So the reference template that is already there, the reference template that is already there. So whatever the extraction of the features from the speech signal, that the pattern we are comparing with already existing reference. Okay, so if the pattern matching is done, we are going to be taking the decision route. The recognized text should be displayed in the output. Right, so this is a block diagram of the speech recognition. We can easily identify so what is happening actually the process. So speaker is recording, the speech. Room acoustic is there, noise, microphone, and everything that will be incorporated in the actual speech that he is speaking. And then at the front end, the signal processing and the feature extraction that can be possible, and the local match is the probability of estimation, and the global decoder, that is the time align, pattern match utterance, everything that can be done in this block, and language model. So we are going to be conclude the semantics with nothing but how the meaningful words we are taken into consideration. Okay. And then at the output of the language model, the word string can be happens. So this is the process of ASR. Now, having discussed some content here, the reflections about what is the goal of the speech recognition. Okay, so we are going to be developing a model that is ASR. So here the input it is can accept is nothing but the acoustic waveform, that the speech as a signal that you are providing as an input to the ASR machine, and we are expecting that into text. Okay, so now the goal of speech recognition is accurately translates the spoken utterances into text, that is speech to text can be possible. Thank you students, thank you for watching this video.